I was muted. Hello, everyone. Welcome to this next live that we're gonna have right here. Oh, okay. I'm still watching the song Citrus. Everything okay? I was a little bit busy, but I'm already here. Yeah, everything is fine. Everything's fine. Don't worry about it. So I really appreciate you guys from being here for being here. I wonder how many espressos is he taking? I'm actually taking. I already took three because that's what I need to work. Maybe because just to approach the language change, that's what I need. At least three espressos, which was what I needed the last live because I was completely blocked. In the end, we actually did another VM yesterday, Israel and me, and we both ended up finding that thing of when we talk about reverse shells in the web environment, it's a little bit complicated. Not everybody does it the same way, but the way that was explained to that particular virtual machine, it was just fucked up. Not the one that I did, the one that we did yesterday. So that's it. But everything is okay. You don't have to worry about it. Thank you for being in this live. And as expected, because that's the reason why we are here. Today we're going to be talking about Linux servers, and we're going to start configuring our Tartar server. But it's not anything about cooking, Mr. Tekinix, which was what you thought last time. Maybe that's the wrong channel for you at the end of the day. But well, hopefully not. Okay, so thank you for being here, everyone. And what we're going to do? We're going to be handling the server that we installed last time. Let me show you a little bit of what we did. And I've already placed three virtual machines that we're going to be using for this lab. Last time we actually installed, let me show you this. I think you guys can see this. Yeah. We installed this virtual machine. You know that we're currently working in Sun Orchestra. But in the previous live, I showed you how to do this specific environment, how to create the environment using VirtualBox. I'm actually doing this because I've changed the instance where I was working at, and I decided to change it to a hypervisor. And what goes on in here is that imagine, it's not just imagining, but all these VMs are in the same network. You'll see that this AVN client has one interface, but I'm actually using it, or I'm going to be using it to manage the first thing that we're going to do, which is configure the SSH server. We're going to do three things, I guess, which is we're going to add routing capabilities through NAT to our server. We're going to add the SSH keys, and we're going to configure the DHCP server. Everything is going to be in the console, so don't worry. It is not thing complex. Everything is going to be okay. Let me just go to Telegram because I think that Mr. Flores got lost with it. I think he found the stream that when it was down, and it was a little bit down, yeah, but we recovered it. There you go. So yes, that's what we're gonna do today. Let me just leave you here. We're gonna do SSH, and I'm gonna explain to you, even though maybe you the guys that you're connected at this time, maybe you already know how to configure this. But this is for new people. That's a little reminder, friendly reminder that this is for new people as well. But maybe you could practice language in the process. And something that's important, that's really important about this, is we're going to scale it up. That means that we're going to start like a little bit slow with the type of practices that we're going to be, or the labs that we're going to be doing, and it is going to end up in a very productive environment. What I mean by that is that you could put this in production, and that would work. But we're going to start from the basics, and then just continue. So what we're gonna do is we already have these VMs. This one has a LAN network connected to the Tartar. Tartar has two network cards. Let me show you. And this one is going to be our one interface. That means that this is the one that's going to provide internet. And this one, which is named HackLab, is going to be a network where all the VMs are going to get the network services for our LAN. Because remember that this server named Tartar is going to be our main server and is going to be our router. And that's what we're going to do today. We're going to convert it, because you can see that the Windows client that is connected directly to that is getting the PIPA protocol working. That means that it is not getting any internet connection. Let me show you a little bit. The Tartar has two VMs, two NIC cards. I'm sorry. The Tartar has two NICs. This one is gonna be the one interface and is going to provide internet access, and the HackLab is going to be the network through that the users are going to use, or the clients in the network are going to use to connect to the internet through passing through this other network that's here. So now everything, you can see that this multi-purpose Windows, which is going to emulate a Windows client, you're going to see that it has only one network and the PIPA protocol is working. For those ones that do not know a PIPA protocol, for those who do not know the automatic private internet protocol addressing, this is actually enabled when the client does not have DHCP working. And the way that the VM does this little connection, let's see if PIPA CCNA, there you go. So the PIPA actually shows what goes on with it gives an automatic IP address, which is not routable, but by the way, it's not routable, but it can be used in order to continue. Hi, bro, Jason Zapata. Welcome, Mr. Zapata. I really appreciate that you're here, man. I was not looking at the comments in Facebook, but that's really good. It's starting and it's ending. It's actually starting, my friend Francisco. I appreciate you a lot, man. Hi, Paranoico Mero. I missed your. I think that today you did put the ping command, because for those who do not know, Mr. Paranoico is our end of NG in the lives. That's what goes on, but that's the way it works. But yeah, I remember that this is being transmitted not only through Facebook, but it is actually being transmitted in YouTube and also in Twitch. You can find us there. Please go to Twitch, because we're reaching the 50 followers. Please go to Twitch and please give a follow to that, and then you'll get a lot of information if you get subscribed to Twitch. But yeah, that's what goes on. Thank you for being here, guys. Now, let me go to the lab. Go back to the lab, and so this protocol goes or shows up whenever there is no DHCP server working, which currently we do not have. Remember that this virtual machine is connected to the same network called HackLab as our Tartar server. Let me just yeah, the Tartar server has two NICs. This is going to provide internet. This is This has no IP record because it's not configured. And now, today we're going to select the network network space that we're going to be using, the network segment that we're going to be using, and we're going to subnet. We're not going to enter into a VLSM, which is the this system is to make subnetting and everything, because it is actually very easy at this point to configure this type of services. So you do not need to learn it. In my opinion, you will learn it because that's what happens. That you need to learn how to do it manually. But at this time of the live, you'll find out that it is really easy to get that working. So that's what's happening. That's what's really happening. So let's get started with this. Everything is going really well, Mr. Zapata. Very well. I'm just, you know that every Saturday we do lives, but these lives are all in English. That's the purpose of this. For those who want to practice, and if we could reach another audience or some other people, that would be amazing. That would be just amazing. Amy Benito, what name of this dashboard? What's the name of the dashboard? This dashboard that you're seeing is an orchestra. This is a hypervisor dedicated to manage XCP-ng instances, which is a I've already talked about it, but I'm gonna make a video, maybe in Spanish, on how does it work. This is a very good alternative to VMware for enterprise, to Proxmox, to QEMU or KVM. That depends really on that. It is for virtual. Yeah, Mr. Amine Benito. Yeah, it's completely for virtual environments. But yeah, that's what's happening. Now, let's get started with this because we need to configure a lot of things and I have to explain a lot of things. Remember that. I'm going to leave in a comment what we're going to have a look at today. We're going to configure the DHCP and we're going to configure the router capabilities for our Linux. So there you go. I leave that. What is best distro? Oh, I think this one is better. In my opinion, we actually have cloud services because I haven't talked about it. But not in this live, not in this stream. But as you may know already, if you follow us, we are a cybersecurity firm based in Mexico. Yeah, and we provide cybersecurity services as well as cloud services. We are also a cloud provider, and we provide cloud backup, web hosting, business mail, cloud app space, which are Nextcloud instances, vCloud, which are virtual private service, and infrastructure as a service. I'm currently the CEO of the company, and it's been there since a long time. I think 2018, it was founded. We founded it in 2018. But yeah, we provide cybersecurity services as well as cloud services with our own cloud. That means that we have our own data center, and we could help you out if you need to put a server on the cloud. And answering your question, if this is better, I think its stability is better than Proxmox, based on what I've actually done in the past. And Tartar, which is I mean, this instance is a manage of a server over here, and it has a system called XCP-ng. Zen Orchestra is a web interface just to administer XCP. XCP-ng. There you go. So XCP-ng is a Zen server based distro, but it is better. In my opinion, it is better. It's fine-tuned, and it's also open source. That's what's very good about this. You could pay licensing, but it's not licensing for the virtual environment. I mean, not for the hypervisor. What you pay licensing for is for this bundle or administration, which includes backups and everything. Now, if you need help putting this in your company in production, we could help you. And let me tell you, our cloud runs at the the different instances that we are currently running are based on XCP because of it has a lot of stability, and we actually make projects that are projects that have to do with the virtualization and networking, and if we need to install or implement a virtual server or hypervisor, we tend to do this. We use this one because it's very, very, very stable. So yeah, that's the story about that. Now, what's this? Okay, there you go. Let's get started. If you have any question, Mr. Amine, go ahead. You're just I'll be so pleased to help you. That's what we're here. Now let's continue with this. Now the Tartar, this is a clean installation, so we do not have anything else installed. Let me just log into this virtual machine. We installed. We actually didn't configure the SSH server. Let me see if we have it installed. Systemctl status SSHD or SSH status. Okay, it's active and running, but we have not configured it. That was because we installed it in the installation process. Now, let me tell you something. When you're installing this type of services, you have to take care of, first of all, what are you going to put in the routing table? Let me show you the lab. What are you gonna get put in the routing table, or the actual SSH service or firewall? I meant firewall. Sorry, I meant firewall. You have to be aware of what you're getting in there. But the first thing that you have to learn when we are talking about managing SSH servers, remember that something I say a lot, and I tell this maybe to everyone that want to get in cybersecurity. It is better to first learn how to implement services than going ahead and being a pen tester, because you have a background, you know how it's built, and it's easier. But it's not so easy for people that are in the world of pen testing or red teaming to go into sysadmin activities or SRE. And the answer is simple. To do the first one, which is pen testing, you need to know how things are built, how to implement an Apache server, an Nginx server, a proxy, how connections are working, how to make subnetting, how to configure a server the way that we're gonna do here. You could tell me, man, at this time there are a lot of videos out there that show you how to do this that you're showing, and there are actually ways. It is way simpler to do this, or way more simple to do this now than it was before. Yeah, but that doesn't give you the basics. That does not give you how the hell things are working. That's why people get stuck, and they find cybersecurity difficult, or sysadmin, in this case is SRE, difficult, because they do not give the time, or do not take the time to learn basics. Well, that's what we're going to do today. So we are currently in this console. Imagine you could do this with VirtualBox. I already showed you how to do this little app in VirtualBox. I'm just going to go ahead and start configuring things. Now, we need to know what IP address we have, and that we can do that with the command IP. IPA will show me what NICs I have. In this case, you can see that it is numbered by 1, 2, and 3, and then it's localhost, ENX0, and ENX1. And let me make you life simpler. If I place the minus C is just an argument. Okay, these are flags. Minus C means colored. How the hell do you know what a command does? You go to man IP, for example, because that's the command that we're using. You could see that right here lays the documentation of the program. So there's no excuse. I don't have internet. You don't need internet, actually. You don't need internet. That's important to do. I'm good in Proximus and exe. That's pretty good, Mr. I mean, it's pretty good. The thing, for example, I have with exe is that now for the ones that are using the paid version of the virtual of the hypervisor, you would find that uh, the licensing has changed. VMware changed that. Before you needed to buy, it was just 16 cores, I think, of processing. Now the minimum requirements are 72, and you have to pay that annually if you need support and everything else. Now the licensing is not going to be perpetual. So many companies are going to find and are going to face that they need to change from one platform to another one. We've in the past we provided services of VMware. We were partners of VMware, but the reality is that they're now focusing on data centers, and the clients are just data centers, and that leaves a lot of companies that have, I don't know, maybe 20 virtual machines or 50 uh, in VMware, facing this problem that they need to pay a lot of licensing, which in the first place was not what they bought. Yeah, that's my thing with VMware. I love VMware. I love VMware. We've actually implemented servers with that with VMware with the ESXi. But at this point, I think there are a lot of alternatives. That really depends on the budget of the client, but I think that we should be open to have those capabilities. I mean, go ahead, try this one. I really encourage you, try this one, and you'll find that it is very, very good. Also, for example, just to tell you one of the benefits it has, if you go right here, you could see backup. This simple characteristic needs a paid licensing of VM backup and replication or something like that, and this is already included. We could migrate VMs because it has a connector to VMware. We could migrate those VMs to this through that connector, and it would work perfectly fine. Plus, it's like I told you, it is completely open source, but you could pay support if you need it. Uh, Beam backup and replication let you make backups like for 4 jobs, like for 10 jobs, if I remember well, because we're partners of Veeam, but we don't sell it that much because clients prefer this type of solutions. Now, backups could go, you could go and throw them to a NAS or to a SAN or whatever you have in your network to storage. But yeah, that is, the little benchmark. I encourage you to try it. But yeah, too much talking about hypervisors. Then we're not gonna continue, huh? Okay, there you go. So, right. Let's get started. Let's go back to basics. Now, look. Let me show you this. So IP minus C will print without print in my console. What goes on? Now I have two NICs. One that doesn't really have a configuration, and the other one that has a DHCP configuration. And we'll set that manually. We'll configure that in static IP, but that's what we're gonna do in a moment. So you have to know some basics of what we're going to configure. This is just, this is for people that are starting with this Linux thing. But the reality is that you also need to know networking and the basics of IT. This is not from zero zero. You need to know some concepts about what we're gonna look at. but we're going to implement services from 0, 0, you know. Just let me see. There you go. Let's continue with this. Now we know that in the network we have a dotted decimal IP of 172.16.250.146. And now we need that would be our one interface. And how do we configure in this scenario where we only have console? But I'm going to use Vim. I don't know if I've already installed it, but I'm going to install apt get install. This is Debian. Vim. I don't remember if I've installed it. Apparently not. And now we already have that installed. There you go. With Control L, we clean the console. And I'm going to use, I think that Nano is already installed. With the cd command, we could go to a server. To a folder. You know something? Remember that if we go to root, this is the root of everything. Remember that I told you that in Linux, everything is a file. So if everything is a file, let me just put it a little bit bigger because it was too small. If everything is a file, the configurations of the files we're going to find them just as good. So I'm going to go in etc. etc stands for edit to config. Now, that by its own name means that here we're going to find everything that we need to configure services or whatever things we have. Most of the time will be services that we have installed. Among those services, we have the SSH. Now, let me enter the SSH right here. Hey! Hello, Mr. Romero. Thank you for being here. Now, today we're doing it in English, but yeah, thank you for being here. I really appreciate that. So, yeah, you were really lost a long time ago. Now, there's the SSH folder, and here you could find a lot of things. Now, I cannot find that SSH folder in my server. I cannot find it. Let me go to apt-get install sshd or SSH, and that'll install the service. Okay. Now, I'm going to change that because, there's a packet manager called apt. Okay, and apt, what does is it let us handle commands and look for packages in the network, and that is the way we can install things into our server. Now, let me show you something. I'm going to use something different that's called aptitude, and I'm gonna install with apt-get install aptitude. There you go. So aptitude let me do the same thing, exactly the same thing. I can look for packages and I can install packages. Remember that the packaging that Debian uses are the .deb packages, and you would see them through our process, But yeah, that's the thing. Now, we have it installed. If we have it installed, it is not going to show us anything like this. Let me see. Aptitude and apt-get, in a sense, it's the same thing, There you go. But that's the same thing. It is just more advanced, in my opinion, and I like it better. Okay. There you go. So, yeah, that's what happens at this point. Now, the file that we're going to use to configure this, well, first of all, how do we start a service? Because we have to know something. If I go to, let me install a packet that we're going to need. Aptitude install net tools. This is very old and it is actually outdated, but I'm going to use it because it's really easy to use. At this point, you could use SS or something like that just to show what is happening in the server. But this one really shows what goes on with no problem. If I go with the netstat command, netstat actually shows me the network status of my server, including what I'm listening to, what's going on, the services that are running. But as you saw, it just dumps out a lot of information. I'm going to check if the service NFTP, there you go. You could see that our service is running. What does that all those zeros mean? What do those zeros mean? That means that we could get the connection, the SSH connection, from every machine that has direct connection to this server. Now, that is already working, and we could access the SSH server through two methods. The first one is through a password, and the other one is through SSH keys. We're going to generate the SSH keys. Now, let me go directly to the config file with ls. You list command with ls -alt. You would list the permissions, and we're going to get into those things, the permissions and how they're handled in Linux compared to what are they, how are they handled in Windows. But this is actually the thing that we're going to be using. The file that matters the most in this folder, at least for the first time that you configure, because then you could actually do it a little bit more interesting, 2 or 3 lines, and that'll be it. It's the sshd config file, which is this one right here. Okay, so I'm going to open with Nano. I prefer Vim, but for most people, you're going to find it complicated to use. No, you know something. We're gonna do it with Vim. We're gonna enter with Vim, or you could use Nano. I don't have any problem with that. No problem with that. Now, Vim, and we're going to name the sshd_config file. What that opens up is the configuration of our service, and you could see that it has. When you find in a config file, normally in Linux, if you have that it has a hashtag, that means that that line is commented out. That means when the service starts, it's not going to take that information. It's just going to ignore it. Now you could see here in the SSH service, you could see that it is actually vanilla. What does that mean? That means that there's no configuration in here. Now let's get started with this. I'm going to escape, and for that I'm going to show you a little bit down. I'm going to click the space key. I'm going to press the escape key. Once I've done the space key, I'm going to put or type the colon, and I'm going to put the Q letter. And that'll take me out from the file. This what you see is what was printed, but I'm not anymore in the file. I'm actually back in the console. I hope that you understood that. Or if you do it with Nano, for example, Nano, the sshd config file, here you could find the instructions of what you need to do. You need to get out. You need to save that. For example, if I want to go, want to get out, I'm just going to press Control X, and that'll take me out of the file. If I want to write it, I would do Control O, for example. And that'll ask me, do you want to write it to this file? Yes. And exit. And that'll write something in the file. So right here, with systemd is a service, systemd, Wikipedia, that substituted init files. And init files is an old system that used to start script manually one by one in Linux. At this time, systemd Linux helps you out to configure this. And what it really does is it manages a lot of things, and that's why many people think that systemd is not that better, because it's not that good. It doesn't It doesn't have good performance. At the end of the day, System D is a service that manages other services and much more, because it actually makes comparisons and tries to check if the health of the file system is okay. Yeah, that's what happens. For me, after set up my SSH key, uh, for my after setup SSH, I'm active PEM white system control. I don't get that much, but yeah, I'm going to show you. I don't really know. For my after setup SSH, I'm active PEM white system control. I don't really get that. But yeah, you activate it with that. You activate it with system control. Or you could do it with another thing. Before going on, tell us how to go out. At least in Vim, yeah. It's a little problem when you get into Vim. But yeah. So, System D. System D helps you to manage a lot of things. Let me see if there's a page of System D in English. Yeah, there you go. So, system-based software suite that provides a array of system components. You could create your own services if you want. This will check out a lot of things. Before this system existed, there was something called init. And init commands or files will help you to start or stop services. The way we did it in the past, it was like etc, for example, right here, I'll write etc init.d DHCP, for example, or SSH in this case, status or stop. Right here is not letting us stop it, but status start is not letting us do that because now System D controls everything. Now, what's the way that we do it right now? It's going to be like system control. Remember that this is for managing daemons. What is a daemon in Linux? What is daemon? Daemon in Linux is not anything from mythology or whatever, or religion. Daemons are Linux. Let me go just through Wikipedia. You know, maybe most of the time Wikipedia does not provide that very good information, but in the case of technology, it has a solid information. So, multitasking computer, a daemon, okay, is a program that runs in the background. That means services in Windows, for example, if you've already managed Windows services, in Linux, we call it daemons. That's the main difference between one and another one. Now, this one that's right here is the SSH daemon, the secure shell daemon. Now, what the hell, Emer? You've actually talked about a lot of things, but what the hell is SSH? Now, SSH it's secure shell. SSH stands for secure shell. That's what it is about. Let me just go back a little bit. This one. Secure shell. Okay. Oh, by the way, please donate to Wikipedia because there's a lot of information right there, and I'm going to do it, and it is a very good website. I mean, it would be so bad if it just gets down. I don't know, just help them. The Secure Shell Protocol, okay, is a cryptographic network for operating network services securely over an unsecured network. It is like a VPN, or it is a connection that has to do with two channels. Those two channels normally share a key. One has a public, the other one has a private key, which I'm going to explain to you today. And what that does, or what that happens with this, is it takes most of our problems out in terms of security, because it is passwordless. The only thing is that you have to share the public key, but that is why it's named the public key. But it is an asymmetric, I think, encrypting. It's an asymmetric protocol. Let me see if it's symmetric or asymmetric, because it has two shared keys. public key cryptographic authenticate, public keys. Let me see. Yeah, symmetric. It's symmetric because it has. Let me show you what it had. What happens in the past, right? So this is what happens. The encrypted communication goes with a secret key. Well, I think it's asymmetric because it has one key and the other one. And what happens is it has two different components. One key that you can share with everybody, and the one that you're going to share just, or that you're going to keep to you, that is not going to be public. But that's what happens in the end. Now, let me show you something, or let me explain to you some concept that you will need. Well, first of all, let me continue with this. The service has already started. System control. If we execute system control status SSH, you would see that it is active and running in the port 22. You could see the name. You could see where the service is saved, whatever. Now, if that is there, that means that we could access this service with no problem. What IP do I have? This one. And we actually created another user. Let me just go right here. We created another user. Just let me consult it. Absolutely. We created the user Ether Cloud that we're going to use to connect. Now, first rule of managing services: you do not access the server with root. You access it with a low privilege user, because then you're going to fuck up. That's what's going to happen. You're going to fuck up the server. Yeah. That was a little rage, but you need that. You need that. So I'm going to access this through the IP address. How do you do that? Very easy. 172.16.250.146. I'm going to go to this virtual machine, which has remember, we have a blog that we could follow. If you go to the website Ether Group, you would find that there's a little pop-up that's going to show the first time you enter, and there you could put your email address, and then you will receive every article that we publish, so you could read it. And currently, they're only in Spanish. They're only in Spanish, but we'll take them in English as well. So let me go to the console. This is a console. I'm going to connect through the one interface. Let me go here. I'm going to go to Debian client right here. This is the 34, and the server has the 146. I'm going to access it. There you go. So right here you could see this is the thing, and the way that I am going to access the virtual server is with the command SSH. That is going to ask me for the user and password, and the way that we put it is the user is going to be Ether Cloud, because we're not going to use root. 172.116.250.146 and the port 22. This is the default port. That means I did not have to place that in the 22, but I could avoid it because it's the default. But if you put it in the port 5,000, 50,000, that is valid. You could put it. We can change that in the server. And you need to enable the SSH for start automatically when starting the machine. Yeah, normally when it is installed through the apt-get, it actually does it. It actually enables it in default. But yeah, what he does is what Amine is saying is true. Remember that this, if you have not seen the Ether Group channel, you would see that there's a playlist of this same course, free course, that we published like 3 years ago for beginners in Spanish. So yeah, the service is actually running, but we're gonna make that enablement and everything afterwards. So the SSH Ether Cloud, this is what we're going to connect to. So Ether Cloud at 172.116, I mean 16, 250, 146. And this would show a little advertisement that if you want to connect, this is going to add something to a file called authorized keys. No, authorized keys, no, known hosts in this virtual machine. Now, I'm going to click, I'm going to go to yes, enter, and now it's going to ask me for the password. I'm going to enter the password. If I remember it. There you go. And now we're in the server through the SSH command. But yeah, that's what we're going to do. Now, this is the remote server, because if I go to IP-CA, you could see now that I have the information of the server. Now, if I go to exit, I'm actually out of the server. But yeah, that's the basic thing that we're configuring right here. Now, I'm going to connect to the server with SSH. Afterwards, we're going to configure the SSH keys. But for now, this is what's going to happen. Now, I'm going to su minus. Remember when we do the su command, we're going to switch user. That's what it means. Switch user. And if we place the minus right there, it's going to take us to the home of the root user, which in the last video, we said that it was dash root dash. That's the home of the user. So there you go. Now we enter the root password, and that's it. We are currently in the remote host. Remember the last time we installed the tools that help us with this. You'll listen a lot of noise because there are people actually working at this time in the office. Because they're given now a maintenance window. There's a maintenance window for our servers that we provide services to our clients. They're having that maintenance window. So yeah, you will listen to some noises. So yeah, you'd see that right here. Last time we installed the VirtualBox things. In this case, they're not VirtualBox. These are the files that we used, the gas utilities that help us get the information, like this one, or turn off the virtual machine gracefully with no problem. But now, what are we going to do? We're going to set up the static IP addresses for our server. And we need two. Let me show you how do we configure this type of things. There you go. Let me go to the let me go in Devina. Debian. Okay, just to show you how it is going to be configured. Look, it's easy, but the information that we have many ways. We're going to do it this way. We could do it with the net plan and all that, but like I told you, we're going to do the basic stuff first. Afterwards, we could level up this all the things that we're doing. Now, where is this file found? Well, boing. There you go. I'm going to go to edit to config. Okay. Then we're going to go to network. Then interfaces. Oh, Vim interfaces. It's not the D. The .d normally means that there's a folder. But the interfaces file. Now, let me get out. Let me show you where I am. And this is the route where, or this is the path, the file path where that is found. Now let me go to BIM, interfaces. There you go. And that is what's happening. If you see, it looks alike, one thing or another one. But now what we're going to do is we're going to configure the other interface. Now for that, we need to know what interfaces we have. We know that we have in the server the ENX0 and ENX1. If you saw, ENX1 is not here. Now let me change these comments just so we could clarify this information. Now this one is going to be the WAN interface. And we're going to create another comment that's going to be the LAN interface. There you go. Now, I'm going to give the auto config, and I'm going to write the name of the other interface, which is the NX1. Auto means that it is going to start that automatically. Now, how are we going to configure this LAN interface? This one is in the DHCP because it's getting the DHCP from the network. Remember that the server has two different NICs. The first one is going to be the one and is going to provide services. And the other one is going to be the LAN and is going to, this one is going to provide internet services, but this one is going to provide all the services to the LAN users. That includes the Debian, well, at this point, not the Debian, but the multipurpose WIN, which is the one that's connected to that network, okay? To the HAP cloud, which has the APIPA working at this time. And APIPA is just there because it doesn't have a DHCP server configured. Let's see if we, at this point and today, we can make that happen. Because it's a lot of information and maybe the live is going to take like 4 hours or so. Now, let me show you this. At this point, I could place iFace ENX1 in it. You see that this one is DHCP. That means that it's going to get an automatic IP. But this one needs to be static. So we're going to change it to static. And right here, we're going to start writing all this information. The address, the net mask, the gateway. And for that, we need to select the segment, the network segment. Now, let me add that as comments right here. And the network segment. And the way that we're going to do that is we need to network say the CDR PDF. Let me see if this one is available. Let me see this one. No. It's because I have one, but I don't. Oh, this one could work. You have to know that there are classes of networks that we could provide. And this really depends on what do you need to do. But I strongly recommend that you take a look at the VLSM, which is a system for subnetting. But there are a lot of videos out there, so I'm not going to explain that to you. And we're going to change the subnet. Obviously, we have, let me go to the server directly through this interface. If I go to Tartar, you could see that there's a network 172.16.250.16. I cannot take a segment from that or an IP from that network. I need to change that. Now, how are you going to change that? We're going to take another network and we need to make a subnet. Now, this is going to be a small network, so I don't need to make it 24. Once again, I'm not going to explain VLSM. But this is what happens. When you select a range, for example, this one, Class C networks, or Class B networks, whatever. you need to select, for example, these reserve are the ones that we can use. This one, or this one for our network. In this case, I'm going to use the 10, but I'm going to use the 10 with some subnet. And this one, the CDR, okay, what it gives us is the range. This is the class interdomain routing. That means what is going to be the size of our network? Is it going to be big or is it going to be small? And right here, I'm going to take this one. For example, if I take the smaller the number, the bigger the network. So I'm going to take, for example, this one is very easy because you have the CDR, the subnet mask, the address, and the wildcard. The wildcard, normally you use it if you're using a routing protocol. We're not going to use routing protocol at this time. But yeah, look at this. What we're going to do is we're going to select, for example, 16 is good because the network is going to be like three or four virtual machines. I do not need more, but you could do it like 24, which is the standard for a home environment, which will give you 256, which in reality is 254, because you need a gateway and you need a broadcast IP. Once again, please learn VLSM. If I find it necessary, I would make a video about it, but I'm not going to cover it. So if I could take, for example, this one, 28 network, that means my net mask needs to be this one. Okay? 28. And that'll give me 14 IPs. One for the gateway, which is going to be our server, and one for the broadcast, which those two I cannot use. And the rest of them, which are from the 2 to the 14, are usable IP addresses. And let me show you that in practice, for example. I'm going to take the segment 10, and I'm going to say network segment right here. It's going to be 10.40.30.1.0/28. That means I have 16 addresses, 14 usable addresses. Because we need to know what is going to be the gateway. We need to know what is going to be the net mask. We need to know what is going to be our broadcast. And that's it. Our gateway is going to be 10.40.30.1. The net mask 255, 255, 255, 28, 240. Hope you're understanding this. And the broadcast is going to be 10.40.30. Broadcast will be 60. There you go. That is it. That's all the information we need. Now, if this is going to be our gateway, the LAN interface is going to be our gateway, then we need to configure that. And for that, we need this information. Just wait a minute. I'm going to be back in a minute. Sorry, I needed to give some uh, indications. But yeah, we're back. Sorry for that. So yeah, that's what we're configuring right here. So at this time, we're going to take that information that we need to configure the IP address. So that means the address, the net mask, the gateway. Yeah. I'm going to make a tab right here. Tab, address, gateway, which this one is not going to have a gateway. Net mask, and I'm going to tell you why. Net mask. And that's it. Why? Why do I only need this instead of all that? Because this is going to be the gateway. So I said the gateway is going to be 10.40.30.1, and the net mask is 255.255.240. And that's it. We already have an IP address. Now what is going to happen? There is a service inside this Linux environment that manages networking, which is named networking. So I'm going to save that. How do you save that in Vim? You give escape, remember escape, colon, write and quit, or X, which is write and quit. There you go. Now, how do I see configuration files without opening them? With the cat command, cat interfaces. And you could see that the configuration seems okay. The name, check out every time that you configure this type of things. Make sure that that all the information is correct, because if it is not correct, the daemon is not going to start. So I'm going to go to the server. This is the SSH connection, but I'm going to go right here because maybe if I restart and there's something wrong in the file, it is not going to start the connection and it's going to cut the connection from this virtual machine. So right here, I'm going to go to the systemctl, restart, networking. Networking. Is networking, okay, not networking. It restarts the networking service. It is apparently fine. If we need to verify that, we'll do with systemctl status. Networking, and yeah, everything is fine. It is actually okay. It's working. Now let me go to the server. Okay, apparently the connection was not cut, and I'm going to verify again the IP addresses to see if there are any changes. And now we can see that there are changes right here. Now the NX1 compared to before, it already has an IP address. Now, you could tell me, okay, but we do not have internet access through that interface. No, but we're going to resolve it. We're going to solve that later on. Now, we have a Windows client over here. We have a Windows virtual machine that is connected to that network. You could see that the network says HackLab, but the APIPA does not give it access because there's no DHCP server. And the Tartar has that 30, and now you can see that it shows that it has the 30.1 interface. The HackLab is connected there. But we need to state imagine there's a wired cable between those two virtual machines. Now, I'm going to get into the Windows machine. And let me see if we can ping that other VM. Spoiler alert, we cannot because we do not have a valid address. We need DHCP for that. And that is what we're going to configure. Now, look at this. CMD, going to go there. And if I go ping, I know that the IP address of the server is 1.40.30.1. But there's no ping connection. Why? Because I do not have an IP address, a valid IP address. How do we solve this? Okay, we're going to go, if we go to Windows R and we go to ncpa.cpl, we will open the networking. We'll right click on the network of the NIC right here. We go to this and we're going to place it to static. It doesn't matter the DNS servers at this time because we do not have internet access. The network at this point between the server and the Windows VM, there's no internet connection. That's what we're going to configure. But now I'm going to place another IP in the segment. Remember that we said that we have a segment right here. Let me take a look at the config file. You could see that our gateway is this one, but the network has 14 usable addresses. We already took one for the gateway. And the other one is a broadcast. So there are 14 usable after those two. That's why this is not 16 completely. So I'm going to take the number 2 for the user. Okay? Number 2 for the user. In this case, the Windows. So I'm going to set up the 10.40.30.2 and 255.255.240. What is the gateway? Well, let me tell you something. The gateway is actually our Linux server, which is running right here. But why? Why is the gateway? Because we stated it like that. After that, we're going to configure that to give routing capabilities so we could go to the internet. But at this time, the server, the Windows machine that is right here does not have internet access. We're going to provide that service. Now, take a look at this. Now, we're going to set up the gateway as 10.40.30.1. But at this time, there's not the DHCP server. No, we're going to configure that. Now, I'm going to accept that one again. And look at that. In that moment that we applied the changes, the network appeared. I'm going to click yes. And take a look at something. If I go and ping the server, 10.40.31, voila, it's already working. There's communication between the server and the client. But there's no internet connection. Look at this. If I go to google.com, nothing. But you already configured, or the virtual machine already has the Google DNS servers configured. Yeah, but there's no internet connection. And for that, we're going to use the routing capabilities of Linux. And this is how your internet and home works. But this is just everything from the back. Now, let's give internet access to this virtual machine. Okay? We do not have a local DNS server in the network because we only have that Linux server, and we also have the Windows machine. That's all we have. But we need to give routing capabilities to that. Now, let me show you how we're going to do that. For that, we're going to use something named IP tables. At this time, there are NF tables or Firewall D or any other service. Yes, but we're going to go back to the basics. So please just stand. We're going to do it. So what the hell is IP tables? Well, IP tables are rules, or a set of rules. Let me go directly to the Linux man page. IP tables is used to set up, maintain, and inspect tables in packet filter rules to the kernel. Now, this is very complicated for people that have never worked with IP tables, but let me show you something. If I go to NetFilter, let me see if there's an image. There's one image that I love to use every time I can. This one. This one. I just love it. And the main thing why I love it is because it shows the whole process of what happens to the packages. You know exactly what happens. Now, what are we going to do to configure all this? Just let me go Are there any questions at this time? I guess no. I think I've been very clear about it. So, I'm looking for my notes. That's all. Okay. Well, yeah. This one is what happens to all the packages when you're using Linux or anything. And when Linux is your firewall, or that is the way that you're getting information from. So the way that it happens, or the way that it works, it just gets in here and it has the IP tables or net filter, which is the name of this. Net filter is a packet manager in the kernel, in the Linux kernel, but it has been changing a lot. But we're going to use IP tables for this. Now, you can see that there's contract, there's mangle, there's that, there's filter. All those are named tables. Okay? All these tables have chains, which are all these that you have horizontally. The vertical things are tables horizontally. Now your packet goes through all this process and gets filtered. What is what we're going to do? We're going to show the Linux server what it's going to do when it receives a package, a packet from this user and wants to go to the internet. What is happening at this time? If I go trace route 1.40.30.1 tracer, it is just going to show me one jump. Okay, or zero, because distance is zero. There's no other thing. But if I want to go to another server, it is actually not going to show anything because it doesn't know how to go. This is routing. Now, can our Linux server become a router? Yes, it can become a router. But for that, we need to enable the capabilities of routing for that servers. And this is what are we going to do? This is what I'm going to show you how to do. For that, I need a package. Remember that for installing packages, I need IP tables. I need a package called IP tables persistent. But just let me show you that. So we have IP tables, and we also have IP tables persistent. I'm going to install both of them. So to install, I'm just going to go aptitude install IP tables and IP tables persistent. Why do I need this persistent? Because we need that to make the rules to be saved when we reboot, because all the rules that we get into the firewall, once we reboot the virtual machine, they're going to be lost. And we do not want that. We want persistent. So yeah, there you go. You say, I was today years old to find IP have highlight. It is just very good. But yeah, it does have that. It does have that. I'm actually barely seeing your message, Mr. Takinux. But yeah, let's continue with this. Now that we have this, oh, forgot the yes. Forgot the yes. Save current rules. Yeah, I do not have any rules configured, so whatever. But yeah, now that we have that done, I'm going to verify with a little command what I showed you. I showed you this. Now I say IP tables. If I run IP table dash save, there's nothing in the tables. IP tables minus T L minus L, nothing. There's nothing in the firewall. That means that the firewall is clean. We do not have anything. The router does not have the capabilities at this point of routing because there's no routes. The firewall also helps you to block traffic. If I just want to allow connection from this server or another server, and I want to block everything else, it is just good. It's just fine. But I'm going to add the capabilities. Now, how do we enable routing in Linux? Because we have to enable it. We have to make it in a file. And for that, the file where we're going to find this wait a minute, I'm just there's a file. If I go with BIM or with Nano, whatever you want, to etc.ctl.com, this file contains information about the routing. And right here, there's an option named IP forward. For IPv4, we're not going to cover in this course IPv6. So this one is commented. I told you previously that if you have a hashtag before the text, that means that it's commented. I'm going to leave it there. And that is it. Now I have routing capabilities. Now, I'm going to escape, colon, right, and like you saw, right here is very, very, very easy to understand. It is. Uncomment the next line to enable package forwarding. Why? Because we need to forward what the client sent to us to the internet using the LAN interface and the WAN interface. So the LAN is going to receive a package and is going to forward it to the other user in the network. I mean, the other NIC in the server, just to go to the internet and vice versa. That's what's going to happen now. Escape, colon, right quit, that's it. Now, this one right here, this one right here needs, I'm just going to, we could reboot the machine. I'm going to reboot it. There you go. You see that is closed. The reboot command does that. And you could see that this cannot find anything actually. There you go. Now we go to Tartar. Tartar is actually rebooting. So let's start. Let's wait for it to reboot. You normally do not need to do this because Linux servers are not, they do not need that you reboot every time. But in this case, I wanted to do this. I'm going to connect again through SSH. I'm going to enter the user password. Then I'm going to escalate to root user. And there you go. We're there. Now, I'm going to go to the file. I'm going to start inserting rules into the firewall to take the traffic that is going to be sent from the Windows client to the internet. How are we going to do that? Using IP tables. And let me show you what is going to happen. We're going to masquerade the thing. Just wait a minute. It's because I have many notes about this. Forwarding. Are there any questions at this time? I think no, but you could tell me. Okay. Just. Mm, okay. There you go. It's right here. Now, this is what we're going to do. Now, to add rules to iptables, as you saw, if I go to iptable save, or actually systemctl start iptables, and I need to enable it, I think. No, I think it's not. Systemctl status iptables. Loaded, enabled. No, it's actually there. It's working. It just does not have any rules. Now, I'm going to add the first one, and let me tell you what is going to happen. If you, I don't know if you've heard of NAT, but NAT is the way that we connect to the internet. You know that every time when you connect from your home network, what happens is you have a LAN network, and when you connect to the internet, you do not use direct connection. You use NAT. What is that? That means that the router, in this case, this is the private network and this is the internet. Imagine this is our private network. The host is going to be the Windows, for example. And that host is going to go to the router. In this case, this is the Linux, and the router has internet access and connection to the LAN with 2 IP addresses. Now, what it is going to happen is we're going to make that our Linux server takes the local addresses, masquerades that into the one address so it can go to the internet, because that other network really has internet access. Yeah. Let me show you what I mean by this. If I go IP route, it will show me how it is going to go to the internet, or what are the default routes that the server is taking. In this case, the default route is via 172.16.251. If I go trace route, that is why the Linux server has internet connection. If I go to google.com, you could see that it goes directly to the network. But it goes to that one, then I go to another network, and then I go to another network. That is NAT, transforming one network to another one. Okay? So that is what is going to do our server. And for that, we need to know some things. Look, if I go to tables, I'm going to say the table NAT, because that is the table that controls that tagging. The NAT minus 8 post routing. Remember that we have this NAT filter thing. The pre-routing, the post routing is right here. That means that when the packet wants to go out, what is going to happen? And we're gonna make it go out through the LAN interface, or no, the WAN interface. That means when the package comes from one network and wants to go to another network, we're going to masquerade that. That means that everything is going to go out with this IP address. So the NX 0 minus J means an action, masquerade. And then once it knows that it has to masquerade the connection, now what we need to do is forward the traffic. That means taking what's coming from this interface, taking it to this one if it wants to go out of the network. Obviously, if the client, in this case, the Windows client, wants to go to the one interface, that is going to end up there in the one. But if it wants to go to Google, for example, it needs to go from this to this interface and then goes to this other interface. Yeah, so that is what's going to happen. And for that, we're going to say IP tables -A forward, okay, -E when the traffic comes from where? ETH0, in this case, ENX0, okay, and the state, don't worry about this, you will understand it, related or established, except that traffic. Okay. State. Oh. -M state. Match state. There you go. And vice versa. If the traffic, IP tables -A forward, -E, ENX1. Oh, I forgot the other one. I'm sorry. I forgot the other one. When it comes from this one and it goes to the other one, the NX1, and the state is related or established, except that in IP tables -A forward, when it comes from the other one, the NX1, that means when the traffic comes from the internet to the local LAN, the NX0 and the state, oh, just accept it. Because it needs to accept the package. Now, if I go to IP table save, look at this. We have the rules that we added. This one is not needed, but these two are needed. No, the three of them are needed, actually. Yeah. But you can see that now we have applied rules to the filter table. And the pre-routing, just apply the masquerade. Now, what is going to happen now? What is going to happen is, if I go to the Windows client and I want to go to, it has a DNS server of this, of the Google DNS servers. If I go to ping, for example, ping Google, now I have internet connection. What is happening in the background? I'm going through the Linux server to the internet. And because I have a valid DNS server config, what I'm going to go is, if I go to google.com, I have internet connection. And there's one again, ethergroup.mx. I have internet connection. Group, I have internet connection to the servers. Now what is happening? Oh, there's the signing. So if you want to go there, go there. And now I have internet connection to that. Now what's happening? What's happening? I'm going to trace route the connection to google.com. How is it taking me to the internet? And this is so visual. You'll see it. When it goes to the internet, it jumps first. There you go. You can see that it jumps to the router, to the gateway, and then goes to the other NIC gateway. Remember that our Linux server has two routes. Let me show these again. There you go. And there you go. You could see that this one has two NICs. This one and this one. Now, if I take from the LAN this one, the 172.16.250, my default via for the server is this one. But the default via for the client is this gateway. So what is happening is I'm going from the user to this NIC, and then it goes to the gateway of this other one, because that's the way it goes. You see? 172.16.251. That is the one. That is the way that it is getting out to the internet. I'm gonna stop it right there. But that is why I have internet access. And in general, that is the way that we provide internet connection through the Windows, even though it doesn't have internet connection directly. I don't know if you understood this. I don't know if you found that. If you have any questions about it, you got it? You guys got it? I'm gonna drink some water because I'm getting sore throat for talking too much. But yeah, now let's configure the DHCP. So we have DHCP service running. Let me go to the server, and we're going to configure the DHCP server. Now, okay, like I told you something. If what happens if I reboot? You go to IP table save. What happens if I reboot this? Let me copy this. If I reboot the virtual machine, what is going to happen? I'm gonna reboot the server. So localhost. So the server right here, it is rebooting. Obviously, the Windows client will not have internet access. It has lost the internet access. But what happens if I go to it wants to go to the internet, but it's not working. And the reason is simple. It doesn't have IP table saved. There are no rules loaded. Like I told you, it is not persistent. Now, what we're going to do? There's a file named IP tables. And for that file, I'm going to go to etc system. Oh, sysconfig, I'm sorry. Oh, it is not here anymore. Let me find it, because find and same IP tables. Etsy IP tables. Let me see, Beam. Etsy IP tables. Rules before, right here. This file does not contain any rules. So when the service of IP table starts, it will look for something in this file, but there's nothing. So what I'm gonna do is I'm gonna paste that. And you could do it this way, for example. I'm gonna restart the service, systemctl, restart IP tables. And look at this. If I go to IP table save, now I have these rules. And it doesn't matter if I reboot. You now would see that I have internet connection. Because it's working. It's currently working. Now that service is working very well. Now, how are you going to do to configure the DHCP server? Well, to do that, we need to install another package, which is the server, the DHCP server. Now, let me just go. DHCP. I mean, aptitude search. I think that this is the ISC DHCP. There you go. It's this one, the ISC DHCP server. So aptitude install, and I'm gonna give it the -y, which is going to answer yes to any question that it that it asks in the process. So you will see that DHCP server is very easy to configure, but yeah. Maybe you want to use Kia instead. Okay, just for those who are not at this point, this is a beginner's course, and we're configuring the server from the beginning. So the SSH pair of keys are not set yet because we're going to configure it not with the SSH key gen command. We're going to configure it manually. We're going to make this, we're making this lab from 0 to hero. But thanks, Mr. Sin in Twitch. Thank you for coming. Thank you for being here. And but yeah, this is a beginner's course, so let them get familiar with this type of things. You know, in the week we could go through the week. We could go in much more complex terms or information. But for this, Saturdays are in English because normally we stream in Spanish, and weekends are just for this Linux server course, which we already have in Spanish, but this is the English version, and we're going to be making this for the beginners. But thank you. That is the real thing to do. Better use a key. So yeah, you want to install this actually, and yeah, I mean, if it's for beginners, why not teach them about the right packages? But I get it. No, yeah. We are going to do it, but it is not about not teaching them, but it is making, this is like the second video, so I want to show them, I actually show them exactly why is that we need things done properly. For example, in the case of SSH keys, I need to give them like the background in cryptography for them to know why the hell do you need an SSH key? And why the hell does it work? But yeah, you're right. We need to do it. So there you go. Now, right here, we have a file in the edit config file folder. I mean, in it, itsy DHCP. We have a file named DHCPD .com, and this is going to have or contain our network segment. You know that we've talked about the CIDR, you know, right here. We've talked about this. We remember I told you, if you do not know about VLSM, I'm not going to get deep into that. But you need to know that to make the segment. And we've actually already choose. What was that? That was in itsy network interfaces. Network interfaces. There you go. Right here. Right here. We have a 10.40.30 network, 28 CIDR. That means that we have only 16 connections. I mean, 16 usable, 14 usable IP addresses in the segment, but this is what we're going to configure. We needed to do this before because that is the way that we're going to set up the segment. If we do not have that, then we're going to have problems. So let me go right here again, and let me show you how are we going to configure the DHCP server. Now, we only have from the number 2 network, because the one is the one is the gateway. 10.40.31 is the gateway. The 16 is going to be the broadcast, and we have from the 2 all the way to the 15th IP address 2 assigned to the network. That means we could access there. Now, what we're going to do? We're going to configure the DHCP server manually. Remember that we are going to, there are other ways at this time to configure these things. But for now, we're going to do it manually. Bien. DHCP 16. Okay. So the way that we're going to set this up is right here. We could have a domain which we're going to provide later on, because I don't know if you knew, but uh, the protocol that supports DHCP, yeah, it's a protocol like that, but it's Dora DHCP. Yeah, Dora is the one that provides that that configurations needed. Dynamic host configuration protocol. But there's something called Dora, which is the one that does all the work. And Dora provides everything that we need. And this is what happens when we activate a DHCP server. You know, Dora is abbreviated this stage of discovering and and assigning in names, because DHCP has the capability of assigning names. It is not just for assigning IP addresses, it actually assigns names as well, but does not resolve the same way as DNS. They are for different purposes. But we could use a domain right here or not. But for this, I need to leave earlier. I'll watch the rest later. I'll see you, Mr. Takinux. I'm actually going to finish the DHCP config and the SSH key configuration. We're gonna leave it for the next for next week, because I also need to live. Remember that Saturdays at 1 p.m. CDMX time or time zone. That is where we start our lives, on Saturdays. But thank you for being here. I really appreciate it, my friend. Thank you, thank you, thank you. Mario Zaragoza is already right. He's already right here in YouTube. Thank you, man. Thank you for being here. It's me, Mario. It's a me, Mario. I really love that, man. But yeah. Okay, let's continue this. I really appreciate that you guys are here. You know. Oh, if you're not, I don't know, Mr. Sin, if you're there still. But we have a Telegram group. If you want to join, I'm gonna leave it to you right here, just in case you want to join. You know. Just wait a minute. Might be a link. There you go. There you go. I'm gonna leave it again in every place I can. Remember that we're streaming on Twitch, Facebook, and YouTube. So yeah, if you want to join, you're welcome to join that community. We normally do CTFs or things that have to do with cybersecurity. But I've already done this course before, but I wanted to do this now in English, just for the purpose of if we could reach some other audience, which would be great. I would really love that. Now, we need to configure the DHCP server. We'll need to configure our DHCP server. For the option, these options are the default ones, but right here, we have the documentation needed in order to configure the DHCP server like that. We're just going to do it from the ground up. And you could also reserve IPs if that's what you want. So right here, DNS update style, I'm just not going to do this. Max list time, default list time. These are just times that are set for every IP list through the server. So now I'm going to, let me try this. I'm going to put it like etherroot.local. And the example DNS domain name servers are the ones that are going to resolve our things. We're going to use the 8s for now, because in the course, or through the course, we're going to learn how to use we're gonna set up our own DHCP, our own DNS server for the local LAN and for everything that we need. So now, after the max list service, we need to state the subnet that we're gonna use. So subnet, or the network segment that we're gonna use, and this time we said that it was going to be 10.40.30. 0, and the net mask is going to be 255.255.255.240. Okay, that is what's going to happen. Now, I'm going to tap this, and we need to set the range. And that the range, we have already taken the number 1, the 30.1, and we cannot take the 16. Now, we're gonna leave the DHCP server working at 10.40.32 because we've already taken the number 1. Then I don't remember if for Debian. Let me see if it is right here. Because option routers, pool shared network. Okay, we'll see. Because I've done this with Alma Linux or Rocky Linux, whatever you'd like to use. Both of them are Rocky, are Red Hat derived. But yeah. So right here, what I'm going to do is I'm going to say range, that one, that is going to be the beginning and the ending. The ending is going to be 10.40.30. Sorry. I'm writing in my notes. So it'll be 10.30, not .40.30. 40.30.15. Yeah, could do it like that. Let me go from 5. Just in case you need servers or whatever, that is it. Now, that's the range. Then, we need to set the subnet. I have my doubts. DHCP server, Debian. So, currently I have my doubts. But yeah, let me see. Because, oh, there you go, yeah. Range and option, yeah. The subnet mask, the broadcast, the routers. So, option, subnet mask. We need to set the subnet mask, which is 255.255.255.240. We need to set also the broadcast option, broadcast address, which is going to be 10.40.30.16. And then we need the gateway option, routers, which is going to be this virtual machine 10.40.30.1, and that's it. With this, we have, just to explain, the network subnet of 10.40 10.40.30.0. This is the network segment or the subnet. And then the range is going to be from the 5 to the 15. The option subnet is going to be this one. Then the subnet mask, the broadcast is that one. That is actually going to happen. Now, we did not configure DHCP 6, version 6 for IPv6. It is only 4. Let me go to systemctl restart DHCP. Start DHCP. Well, I don't know if it's ISC. DHCP server. My God. Oh, it's DHCPD. My God. I don't know if this is the ISC systemctl status ISC DHCP. Oh, there you go. It's the ISC DHCP. Now it has failed, but I'm gonna restart it because it didn't have any configuration whatsoever. So restart. Okay, there's a journal. Journal normally goes there when there's an error in the configuration normally. ISC DHCP server. And what happened? Default list time 16, semicolon expect. Okay, maybe I did something wrong with this. Let me go again to the DHCP, DHCPD.com, DHCPD.com. Where's a column? Oh, right here. It was expected right here after everything. So let me go again. Systemctl restart. Oh my God. Now, okay. It didn't like that one. Semicolon. Oh. I see what's happening. Right here, I missed an 8. So, yeah, restore that. And now we're gonna verify the status of that service. Oh, now you need the one that I took away, huh? Let me see. Restart the service. Failed. Let me see. Let me see what goes on. Okay. It complains about the DHCP no subnet 6. Not configured to listen on any interfaces. Let me see. Systemctl status DHC ISC DHCP service is failed. Remaining yeah, it is because it does not have any DHCP6 config. Let me see something. Because BIM, again, we're going to check out the, oh my God. We're going to check out the config file just for now. There you go. So, integrate the local, there you go. Authoritative. There you go. Let me see if it goes or not. No. Again. Journal SE. Let me see. Not configured to listen in any interfaces. What do you mean by that? I normally don't set that up. But maybe it wants it. So, not configured to listen on any interfaces. This is the DHCP one start. It says, okay. Okay. I got the same issue. If config. interfaces. Okay, let me see if I find that file. It was not required before, so default default what? ISC DHCP server. Oh, there you go. So it needs an interface. So right here we're going to add the interface that's going to have that service in one, and systemctl restart ISC DHCP. Now let me see if that does not provide an error. But now we do not have, it is going to show a warning because we did not configure IPv6. So status ISC DHCP the service. There you go. But yeah, now it's working. Now systemctl enable SSH, ISC DHCP D server dot service is not a service. ISC, what do you mean it's not a service? Systemctl enable is not an active executing enable. Okay, now it has to be enabled. Where's loaded? Okay, we're gonna try it. But now our network has the capabilities of giving out IP addresses. Now we're gonna try that. We are going to try that. Let me see right here. What I'm going to do is I'm going to go to the client and I'm going to remove the network config that we did, which is right here. There you go. There you go. Right here. I'm going to delete this and this, and I'm going to renew the network connection and get another IP address. Now, what we're going to see at this time? We go to cmd ipconfig all. You could see that now I have number 5, which is the first IP address that we provided from the server. We go to the DHCP, DHCPD.com. You will see that right here, we started our range from the 5th IP. Now, that's what it took, the 5th IP, and now it has DNS servers provided from the network, from the server, and everything is okay to navigate right now. So we're gonna stop there. The SSH key pairing, we're gonna do it afterwards. But now we're just gonna leave it right here. Remember that this course is for introduction, to Linux server managing. So just be patient. If you already know a lot of concepts, I really appreciate that you coming out the things that we need to do. But people that are learning maybe need to get, a little bit chunk by chunk of information to make it work. But thank you very much, just for everybody that is in one of the 3 streams that we have at this time. But remember, through the week, we're going to be making CTF. I think that we already finished the last machine. Remember that this live was sponsored by us. Who's Ether Group? What's Ether Group? Well, Ether Group is a company, a cybersecurity company based in Mexico, and we provide technology services like MISP, as well as cloud services and cybersecurity. Vulnerability analysis, pen testing, GRP planning. If you need help with implementing virtualization or whatever, we could do that as well. And we also have a branch called Ether Cloud, which Ether Cloud is a cloud where we host our own services, cloud services, And we could also help you if you need an implementation of virtual servers. We do not have any problem with that. We'll be so glad to help you. Just contact us. You see that we have our blog. Check it out. And we have our YouTube channel where we save all these lives and everything that we've published before. And we normally stream in Spanish, but weekends, especially Saturday, we stream in English. This course that we're starting from the ground up, called a Linux server course for beginners. So just if you want to join us, go ahead and join us. So thank you very much. I really appreciate that. And I think that's all for today. Really appreciate Mr. Mario, Amine, Luis Romero, Paranoico, Francisco, Jason Zapata, and Taquinux, Mr. Sim. Thank you for coming up this time. So that's it. Oh, if you want to join the mailing list for every article that we publish, just in the main page of either group, you'll find it. That's it. So thank you very much for having us today. And please drink coffee. Not that much, because then you'll get crazy, just like I do sometimes, with a lot of espressos in my head and in my body, I guess. I think I meant you can see what's happening. And I'll see you at Ragnarok. Okay. So goodbye. Thank you. Thank you very much.